The time spent by shoppers at a store is approximately normally distributed with a mean of 31 minutes and a standard deviation of 6 minutes. If 2,850 shoppers are expected to visit the store, the number of shoppers estimated to spend between 25 and 37 minutes in the store is closest to what? Let's start by seeing how many standard deviations below the mean is 25. If we take our mean and minus one standard deviation, we get 25. So 25 is one standard deviation below the mean. Let's do the same thing with 37. Let's add a standard deviation to 31 and we get straight to 37. So we know 37 is one standard deviation above the mean. So we've got our bell curve. If that's the mean, this is our mean minus one standard deviation, and this is our mean plus one standard deviation. Many of the diagrams you have, we know between this point and this point is 34%, and between this point and this point is also 34%. So the amount of data that lies between these 2 points is going to be 68% of the data. Now, to figure out how many shoppers are going to spend between 25 and 37 minutes, we need to know what is 68% of the total amount of shoppers, 2,850. So 68% of 2,850, which is 1,938. Now that number is closest to 1,900, and that is our correct answer.
This question asks, which of the following statements is not true? So let's go through each of them until we find one that isn't true. We've got more than 50% of the outer suburbs have population densities below 2,000 people per square kilometre. So let's look at our outer suburbs box plot and see where 2,000 lies. 2,000 is just above our median line. Now we know on either side of the median is 50% of the data. So if 2,000 is about here, then we can probably say that more than 50% of the data lies below this 2,000 mark. So this statement is true. More than 75% of the inner suburbs have population densities below 6,000. Alright, let's see where 6,000 lines up with our inner suburbs box plot. If you're careful, it hits about there, which is just above where our box ends, which is Q3. Now we should know that below Q3, that's 75% of our data. So similarly with this one, if 6,000 lands just above Q3, then more than 75% of the data is below 6,000. So this statement is also true. Population densities are more variable in the outer suburbs than in the inner suburbs. Just using your eye, you can see that the inner suburbs box plot has a much wider spread than the outer suburbs box plot. So in fact, the inner suburbs population density is more variable than the outer suburbs. So this one is not true. Now, just to be sure, let's double check the last couple. This one, the median population density of the inner suburbs is approximately 4,400. Well, take our median line and go down carefully, we will find that it is just about 4,400. So this statement is true. The last one, population densities are on average higher in the inner suburbs than the outer suburbs. We can definitely see that. So on average, population densities are larger than in the outer suburbs. You can even just take the median inner suburbs, 4,400, the median for the outer suburbs, under 2,000. So this is the only option that is not true.
A single back-to-back stem plot would be an appropriate graphical tool to investigate the association between a car's speed in kilometers per hour and what other variable. We've got this chart in our notes. If we look at a back-to-back stem plot, the types of variables that are best displayed in a back-to-back stem plot is a numerical variable and a categorical variable that only has two categories. A car's speed in kilometers per hour is a numerical variable. So let's see which one of these options is a categorical variable with only two categories. The driver's age in years is numerical, so not that one. The car's color, there's given us four options, so not that one. A car's fuel consumption, again, that is a numerical variable. Average distance traveled, that's numerical. And the last one, the driver's sex, female or male. That would be our categorical variable with only two categories. So that would be our correct answer.
A large study of secondary school male students shows that there is a negative association between the time spent playing sport each week and the time spent playing computer games. From this information, what can we conclude? If you read through all five of these options, you will see that the one that makes the most sense and that is most viable is this fourth option. Male students who tend to spend more time playing sport tend to spend less time playing computer games. There's two reasons for that one. The first is the direction. We say that it's a negative association, which means that male students who are spending more time playing sport are playing less time computer games. So that's our negative association. The next one is the fact that it is only an association. If you look at this one, encouraging male students to spend less time playing sport will increase the time they spend playing computer games. This is just an association. The word will indicates that it's a guarantee. What happens if you have an outlier? So there is no guarantees here. The word tend here is very important. That's kind of like saying, yeah, on average, male students who spend more time playing sport will, on average, spend less time playing computer games. So that one will be our correct answer. It is suggested that the cost of heating a house depends on the type of fuel used. Which is the explanatory variable and which is the response variable? We can figure this out by the way the question is worded. It suggests that the cost of heating a house depends on the type of fuel. The way that it's worded makes me think that the cost of heating a house is a response to the type of fuel used. So we're saying the type of fuel explains the cost. So fuel will be our explanatory variable and the cost will be our response variable. Describe the direction, form, and strength of this association. Straight away, we can see that it is going upwards, so it is a positive direction. So it's going to be one of these two. It looks like a straight line to me, so I think it is a linear, which already knocks out this last one, and the strength is strong for both these ones. So I would describe this association as positive, linear, and strong.
Here we have calculate the correlation coefficient to 3 decimal places for the association between daily maximum and minimum temperatures, and our data is shown there. So to calculate the correlation coefficient between two variables, you want to start by going to statistics. Let's name this one max, about maximum, and this one minimum. Now let's just fill out our data. Okay, once we've filled out our data, we go Calc, Regression, Linear Regression. We need to make sure we select our correct X and Y variables, hit OK, and we get our statistics here. So our correlation coefficient is 0.818, rounding to 3 decimal places. The coefficient of determination is 64%. What is the correlation coefficient? So we should remember that if the coefficient of determination is 64%, is the same as 0.64. And that is r squared. So to find r, we need to find the square root of 0.64. And that is equal to 0.8. But remember, what happens if you square a negative number? If you square a negative number, then you get the positive number back as well. So really, the square root of 0.64 could be 0.8 or negative 0.8. Because the question doesn't give us any indication whether the direction is positive or negative, our answer would be 0.8 or negative 0.8.
The coefficient of determination tells us that, on average, 71% of the variation in ice cream sales can be explained by the variation in the daily temperature. The remaining something percent can be explained by other factors, such as whether it was a weekday or weekend. This remaining percentage is just what is ever left over after the 71%. So if we take 100 minus 71, we end up with 29.
Data was collected to investigate the association between the following two variables. We have age, and the categories are 29 and under, 30 to 59, and 60 and over. And uses public transport, options of being yes or no. Which of the following is appropriate to use in the statistical analysis of this association? The two variables that they've given us here, usually age is a numerical variable that is discrete. But they've actually given us 3 different categories here. So in this instance, age is a categorical variable, and uses public transport, yes or no, is also categorical. So they've given us 2 categorical variables. So the best way to show this is using a segmented bar chart or a side-by-side bar chart. The only option here given is a segmented bar chart, so that would be our correct answer.